Well, Michael, they just let us loose. So we get to just get started, right?
You bet.
Let's get the party started.
Let's get the party started.
I got caffeine here. It should be beer, but you know, this time of day.
I was gonna say, isn't it almost happy hour or social hour or some kind of hour?
We'll do what we can.
Exactly. So looks like we have the folks starting to join in. We want to make sure they're here for your Ask Me Anything with Michael Bolton. Michael, thanks for joining us. As Costa referred to you earlier, the legend. And we've talked about this before, so in case people didn't hear the interview we did with you earlier, those books we're looking at behind you, those are real.
Yeah, it's like that bit from The Great Gatsby where Wolfsheim says, "They're real," you know, as though that's an astonishing thing. Well, you see the ones I got in front of me.
Right? All the books. He's got all the books. So, well, let's, we got a few questions that we were able to get. So you may not have seen these yet, but I have. So the first question we had, Michael, was Spaz Genove, and he asked, COVID impact, and it is a 3-part question. Don't worry, we won't do it Miss America style where we give you all 3 of the questions at once. We'll do it one at a time. How about that? Good. So the first question was, how has the COVID situation changed the way we test?
Well, look around, you know, you tell me. But I can tell you what my experience is, certainly, and that is I'm not in direct face-to-face spontaneous interaction with people. That's a big deal. We are not meeting each other in the hallway. We're not meeting each other in the break room. We're not bumping into each other. We're not standing in front of the same whiteboards. We're not having those serendipitous moments. We're not having the developers looking over our shoulders or us looking over the developers' shoulders into the same screen. Not by accident. That's got to be done in a very calculated way these days. And I think that's ultimately dangerous and won't work very well in the long run. We'll be able to cope for a little while doing that. But it is our nature as human beings to be social, to be able to see each other's bodies as we talk. You know, everybody's had this experience lately, right? Where, you know, there's people just in front of the screen like this, and you're not seeing this whole setup that I've got here is quite deliberately set up in such a way that I'm back from the camera some. So you can see my body language. You can see when I'm trying to make a point. You can see when I'm, you know, doing this. But, you know, for much of the time, we've got people doing this, and, you know, their hands are on there on their keyboards. And we're missing a whole bunch of natural vocabulary. Jerry Weinberg, there you go, whoever's, you know, ringing the Jerry Weinberg bell whenever I mention his name, now's your time. But Jerry pointed out that when we go into a room, sometimes we can smell when the team is under stress, right? Because nobody's bathed, right? You know, if people haven't gone home to wash, and it, you know, of course, North Americans especially freak out when you even mention the concept of smell, but it's part of what we do. When I, one of the things, every time I go into a development shop where I know things are working pretty well, there's a smell of coffee, and it's good coffee, right? There's the hum of the activity around us. There's things that we're hearing in the background, and all of this affects our testing, because all of it, everything that happens, if you're a good tester, everything that's happening in the development process around you, within earshot, within eyeshot, everything is information. Everything is information. So when we're on one of those Zoom meetings where, you know, somebody's participating in the meeting and they're really super distracted, their audio's off and their screen is off, I don't even know if they're there. So that's a big way in which I think we should worry about it. And I get the impulse for remote work. That sounds kind of like, you know, fun. You don't have to commute or none of that. But that also means that a lot of people who might otherwise be reading on the bus or listening to audiobooks in the car aren't necessarily doing that. So there's all kinds of effects, and they're subtle and they're social. And this is something that bothers me. I have to say about the way we think about testing, even normally, is we just leave out those social dimensions and those social aspects that are so important. We're people working together on a project. What was the second question?
Very good. You kind of led into it there with your answer around the social impact. So the next question was more general. In general, how did the pandemic affect our profession or our industry? So any changes around technologies, tools, acceleration, deceleration, anything there?
Well, again, even more than usual, our work is being mediated. That is to say, there's something in between us and the work. And Marshall McLuhan, because I can't resist, you know, me being me.
This is my favorite part, because this is how we know you weren't lying. These are real books.
Yeah. This is a really cool book, Understanding Media. And this is an even cooler book for people in the software business because it was written by a guy who used to be an IT manager. Those books are, of course, on the subject of Marshall McLuhan, who is famous for saying the medium is the message, an expression which is much misunderstood. What he was pointing out is that the significance of a medium is the important thing, the impact that it has on the way we do stuff. The container that something comes in tells us something about the significance of it, the importance of it. Here's a for instance, when you're tweeting to a politician on Twitter, right? That sends a certain kind of message. Phoning the politician's office or sending a letter to the politician, that frames the message in a whole different way. So now a whole bunch of our work is being mediated through Zoom and through Teams and through WebEx and through all those other different media. And these things are getting in between us and the work. And they're getting in between us and, between each other. And I think that's a big deal. I think that's a very big deal, and it's not to the good necessarily, because, as McLuhan pointed out, media extend, enhance, accelerate, intensify, enable human capabilities in some form. And the most important thing to remember is that the media are agnostic. So Zoom is agnostic about whether I'm a good collaborator or a bad one. Zoom is agnostic about whether I've got good motivations or bad motivations. Zoom is agnostic about whether I'm a careful person or a not so careful person. So whatever I'm like, the medium amplifies me. It amplifies my good parts and my bad parts. It extends my capacity to be angelic and virtuosic, and it extends my capacity to be a sloppy schlub, a villain. So that's one thing. Another thing is, I don't know.
I ask a follow-up?
Sure, yeah, absolutely.
Because you brought up the media. So this is just one that comes to mind with what you just mentioned. Do you know Jaron Lanier?
Yeah, absolutely. Right.
The Conscience of Silicon Valley. Do you have his? Oh, I hope you have his books. This is fun. This is like a game show.
You Are Not a Gadget is in here someplace. Actually, no, You Are Not a Gadget is downstairs in my bedroom.
It's in a special place. It's not even up here.
Yeah. I think it's downstairs. I'm pretty sure it's downstairs. It sat up here for a while. I took it down recently because I read another thing. Yeah, Jaron is
So let's talk about, Michael, because you brought it up, right? It accentuating, de-accentuating.
Yep.
You know me, I won't not get controversial. So he wrote a book, The 10 Reasons Why You Should Quit Social Media Right Now.
Yeah.
And
I've
some
got that
people may
one
not
too.
be aware of this book, but any comments on that? Because it kind of goes along with what you're saying of amplification or echo chambers or any of that thinking.
Well, I want to be careful about what we mean by media here, because that is potentially confusing. A medium to McLuhan is look at the wine, is anything, including wine, that humans create or use in order to effect a change. So this is a medium. And in particular, the thing that got him started was that is a medium. Phonetic writing is a medium. This mug of coffee is a medium. This toothbrush is a medium.
This you have a toothbrush in there. How long? You must stay in there a long time.
Well, I'm cleaning I was cleaning my banjo with it actually the other day. This is a medium. So this extends and intensifies and amplifies our capacity to be healthy. But it also intensifies and accelerates and amplifies our distance from one another, right? So I love Jaron's stuff, and I love his book, but I did want to be careful about the nature of media, the kind of media that we're talking about. For me, and for Derek de Kerkhoff, and for Mark Fetterman, who I have coffee with occasionally, lucky enough to live in Toronto. A medium is anything that you can see in this room that I might use, and anything you can see around you that people are using in order to effect a change. And software is a medium. Software just in general is a medium. Your IDE is a medium. But the key to understanding the role of media is that they extend us in every direction at once, all at the same time. And of course, Jaron is looking at social media in ways that they accelerate not so good stuff. But then I look at the way my daughter interacts with some of her friends on social media, and because they're not mean kids, they're nice kids, and they're good kids, and they're collaborative kids, I've seen them using, not Instagram, the other one, Snapchat. I've seen them using those things in order to help other kids out of depression and out of sadness and out of some kind of rut that they're in. So what is happening right now, interestingly, the virus is mediating us. Right? It's a medium too, although we're not using it necessarily so intentionally.
Final part to this question.
Yep.
The final part was, what other changes or impacts do you think we can expect in the short term?
I know that there are other questions of this nature coming up, but as I get older, I get smarter in one sense only, and that is I try not to make predictions about the future. I think we can anticipate that testing, yay testing, rapid testing, yay rapid testing, in the form where we can do quick household tests, right, for coronavirus. That will be a game changer. That will change the game, and that's on the way. We can reasonably anticipate those things. We can reasonably anticipate a vaccine. Here's another thing that we can reasonably anticipate in the long or the short term, and that is this isn't going to be the last time this happens in human history. And another thing that we can anticipate in, maybe not by the time I shuffle off, but maybe before that, we could anticipate coronal mass ejections, the sun giving a big hiccup and blowing away everything electronic in the world. We could anticipate that. And I'm serious about that. It could be everything, all the satellites, all the GPSs, the power grid, because the power grid did go down in Quebec as a result of that in 1989, I believe. So I think it would be a bad idea to try to predict what's going to happen, but to prepare for it might be a better idea. We can expect various forms of trouble along the way, and we need to be resilient to that.
Good point. So prepare. I want to take, if it's okay, Michael, I'm going to take, we have a whole bunch of pre-done questions that viewers submitted prior to the event, but we've got some folks on the line that asked some questions. So Charles asked a question around optimal QA resource management model. So dedicated team versus dedicated resources within scrums versus matrix management of core QA specialists assigned as needed to ARTs.
What's an ART?
Yeah, I was just going to ask that myself. Charles, what's an ART? Can you tell
You can
us?
unmute, Charles. I'd be glad if you did.
Yeah, I was just going to ask that. I thought you probably knew and I just didn't know.
Agile rapid testing.
Oh, there you go. They gave you a new acronym.
I don't know. Here's what I see. Agile release train. Okay.
Oh, there we go.
Okay.
Okay.
Here's what I see, Charles. I'm not good at making myself popular.
Hey, I said we were going to get controversial, so we don't need to be popular.
Here's what I see. When I look at that, my reaction to it is it's really abstract. It's really abstract. And what I would plead is that we get around some of the language of that a little bit, and just how can we get work done better, right? Dedicated team versus dedicated resources. Do you mean people? Do you mean people assigned to a particular team? I think that's what you mean. So my friend James and I chat about this sometimes. He loves to be known as a resource because he likes to be a resource for other people. I have a squeamish feeling when I hear about that. So let me see if I can interpret this a little bit better for my own head. Because I want to honor the question. I don't want to let my own biases take me off my rails here. I believe that a tester should be able to respond to any context. That's what we try to teach people in RST, rapid software testing. It seems to me that I need to respond to wherever I'm at. Now, how somebody sets this stuff up is, to my mind, up to them. What I would say is I think it's a great thing for testers to work closely with developers in terms of trying to cultivate social proximity and reduce social distance, not in the COVID sense, but trying to, we're understanding how social distancing is a thing that we don't like very much, right? We like to be socially close to one another. At the same time, testers need to develop and cultivate critical distance. That is to say, we need to continue to think differently from the programmers. And I'd like to offer a really straightforward way of doing that. And that is to say that the developer's mindset is focused on this statement. I'm here to make your problems go away. I'm here to make trouble go away. And that the tester's mindset is focused on, I'm here to find trouble wherever I look. That's why we're here as testers. We're here to find problems. So how you set that up, Charles, I'm agnostic about kind of my, I love the idea of a testing guild, right? A community of testers within an organization that talks to each other. I like the idea of testers working, cheek by jowl with developers. I think any of those things can work in any kind of way you like that responds to the needs of the project. But look around you and ask, does this work for us? And to the degree it does, do that and do more of it until it doesn't anymore. And to the degree that it doesn't, stop doing that and start doing little experiments whereby you learn something more about it. My comfort level is greatest when I'm just, I'm here and the developer is just over there. We have a nice social bond, but we've got good critical distance between us. I'm looking for problems. The developer is looking to build things, and that works. I hope that answers your question in a way that is helpful. And if it's not, let me know, and we'll take another bash at it. I saw some of the earlier questions. I got some energy for some of them as well, because I think they're important. But can I say this? Because this has been another itch that's been at me the whole conference so far. Please, people, automating is not the goal. Automation is not the goal. Automation is a means to an end. Can we, 10 years ago it was process. People were talking about process. Can we please focus on this? As a tester, building the product is really important. It makes testing easier and faster if I can get my hands on a build that I can test. And it is really useful for the programmers to be able to do fast, shallow testing that allows them to confirm that what they've done is reasonably close to what they intended to do. And there is a sort of domain of testing that is oriented towards that. I might call that the discipline frame for testing. In fact, would you indulge me? Can I share my screen for a sec?
Yeah, share your screen.
Okay. I want to try to get this. What does the business want? The business wants a high value product, right? And because that's how it's going to stay in business. And it wants something it can sell. So we better build it. And we want to keep the cost of development low. If we keep the cost of development low, then the business is sustainable. And we want to study what we built. And that's how the business that's how we get to find out whether the business really got what it really wanted. Okay, now that's great, but what could go wrong? Here's 4 things that could go wrong. We could be unclear, uncertain about what the customers want the product to do, and therefore we might be unclear on how to build it. So it's a really good idea, which is what some of the speakers, Seb in particular, were talking about in terms of EDD. But I gotta emphasize, that's a design process. There is a testing element to it, and the testing element to it is not, given that I do this, when I do this, our job as testers in that context, in that moment, is to say, yeah, but what can go wrong here, right? How might this go wrong? What might we be missing from this? Then, as we've developed our intentions for the product, we might be committing, and by we, I mean the whole development team. Well, when I say that, I really mean the developers, might be committing easy to find and avoidable errors as we try to build the product. That's the second thing that can go wrong. A third thing that can go wrong is it might be hard to know what to build, which is why we try to do stuff in the upper left, upper right reasonably well. It might be hard for us to avoid errors, so lower right, and it might be hard for us to identify deep problems in the product. And those deep problems are problems that might escape even a highly disciplined and well-functioning development process. That is to say, there's always a possibility that we're going to be surprised by something in the product that is threatening to its value. Therefore, why do we have testers? Because the business wants answers to these questions. And I think a lot of the questions that I get in circumstances like this have to do with the fact that we've kind of lost, we're adrift on these questions. What is the actual status of the product? That's what the business wants to know. And more than anything else from the testers, the business wants to know, are there problems that threaten the value of the product or the on-time success full completion of our work. And testing is how we find out about that. Testing is how we learn about uncertainty in the product. Testing is how we expose uncertainty and problems like that. So let's go here for just a sec. Yep. Unhide that. There we go. Okay, so those are the problems that we could run into. So 4 frames for testing, 4 ways for testing to address business risk. We could get clear on our intentions by doing design-focused testing and review. That's what the BDD stuff is all about, to help us discover what the customer really wants. We might be committing easily found errors. So for that, we do review and we do pairing and we do shallow testing. We do low-level, unit-level, integration-level output checking to help us to confirm that what we've done is reasonably close to what we wanted to do. We have a preparation frame for testing in which we are advocating for practical testability, trying to make our product and our project amenable to testing and to make testing work deeper and faster and easier and efficient. And then what we call the realization frame, deep testing, getting experience with the product, That's the thing that we need to do, because I think we've got a kind of vitamin deficiency these days. Our vitamin deficiency is that we're getting all kinds of attention being paid to this and this and this, right? This is about our build pipeline to a great degree. And this is about, unit checking and integration checks and stuff like that. And this is about the BDD stuff. But I think we're malnourished in the sense that when people are focused on intentions, they're not thinking about failure. And it's our job to help people recognize failure and to ask for testability. Developers like to code, right? Developers like coding. Whoa, there's a bug. What a bug, terrible bug. Let's expose that. Developers like to program, and lots of testers like to program too in here, but lots of programmers think that that's all there is to testing. But there's a big difference between checking the build and testing the product. And then over here, there we go. I'll go up one. There we go. There's DevOpsy stuff and preparation, but very few people in the project are focused on testability, making the product easier to test, more amenable to testing. And testability doesn't get it put into the product by accident. We need testers to advocate for that. And then very few testers and very few developers have the determination and the skill and the patience and the diversification to test a product deeply. And then the worst thing about it is people call that manual testing. So I wanted to get that. This is not a direct answer to any particular question, but it informs my answers to a bunch of other questions. Because, for example, I know there's a question about risk, and I know there's a question about AI. My reaction to that, stop sharing, there we go. My reaction to that is, if we're thinking about AI, let's not worry about how it's going to make us lose our jobs, or let's think about problems. Let's think about finding problems, and if we're testing AI, let's think about the kinds of problems and risks that are associated with AI. And a lot of the discourse, I'm kind of a little bit frustrated about it. A lot of the discourse is not talking about problems. You get a lot of testers saying, well, I don't want to find problems, I want to prevent problems. You can't prevent problems as a tester. Even if you're in a review meeting, when somebody says, I think the product should do this, and we say, wait a minute, isn't there a problem with that? We haven't prevented the problem. What we have done, maybe, is we've helped them to prevent the problem from going any further. But we haven't prevented the problem. So as a tester, I don't prevent bugs. I find bugs. And I'm happy about finding bugs because that's helpful. That's my role. That's what I'm excited about. And that makes me weird because most people don't like thinking about problems. They're like, Jerry Weinberg pointed out, the thing about problems, when he wrote a chapter in this book right here, This, so far as we know, is the first book that contained a chapter on testing the way we think of testing, the context-driven community, the rapid software testing community thinks about testing. And Jerry said when he wrote that chapter, he got a whole lot of crap for it. He said, from the reaction I got, he says, I might as well have been writing about human excrement. And that's a quote. This is not suitable. Why would you talk about errors like this? Well, we got to talk about errors, because if we don't talk about errors, we're not going to find errors, and we're not going to fix errors. So there we go. I'm channeling Rob Sabran or something, I think.
I know. There you go. I miss him. All right. I haven't seen him in a while, forever either. But Ivan wants to weigh in, Michael. So we're going to let Ivan in.
Hey, Ivan, come on. Hey, how you doing?
Good so far. So
right.
One of the things that I wanted to ask is, I have been recently assigned to a particularly fragile project that has a lot of legacy issues, and the team, and actually the entire company, doesn't have a lot of visibility, especially in-depth visibility into the issues that are present. So I was wondering, what is a fast approach to estimate the current quality, and what are the highest risk areas it has, if possible, without just tossing it to users and seeing what comes up.
Okay, so I'm going to share my screen again, if that's okay.
Sure.
Because this excites me, this notion. So the classic idea about risk analysis is probability times impact, right?
Yep.
Yeah, okay. Well, I got a problem with that, because what does that even mean? I mean, probability has a couple of different forms. There's the casino style probability, right? Where a ball's going to fall on a roulette wheel, or you know, what number is going to come up at the craps table. But that's a bounded circumstance, right? That's a circumstance where there's only one of 12 possibilities, or it's actually, come to think of it, one of 11 possibilities for numbers to come up on the dice, and then you can calculate the probability of each combination, the probability of a 2 and a 6 and all, or 7 and all that. And you can put that on a table, and you can identify, you can calculate that. That's what we call aleatory probability. It's probability associated with dice. But there's a whole different kind of probability, epistemic probability, where there's a whole bunch of factors and they're not bounded, right? They're not limited by stuff like it. Ivan, the probability that you are a basketball player. Well, I don't know anything about that. I don't know whether you play basketball or not. I don't know whether you're a real tall dude. Now, if I saw you and I noticed that you were tall, I would think, maybe he's more likely to be a basketball player. But that's epistemic probability. It's not calculable. There's a whole bunch of different factors there, and those things change over time. So calculating risk, it seems to me kind of crazy, because then there's the impact thing. And the impact thing is about something that hasn't happened yet. And it's about who it affects, how many people it affects. What if somebody dies, but just one person dies? Or what if one person dies every now and again? Or what if a problem doesn't affect end users, but it keeps database administrators, out late? What if a problem affects the bottom line? Well, we don't know any of that stuff, none of it. And we can't calculate it because there are way too many independent variables in it. So what if we thought about it a different way? My proposal would be to think about risk in a whole different way. Because this whole business of trying to slap a number on risk is just a way, I think, to distance ourselves from it, to rationalize it, or to intellectualize it in a way that is not actually terribly intellectually rigorous, as far as I'm concerned. Actual people who actually study risk, they don't talk like that. When we look at what the risk analysis people say, the people who study quantitative risk assessment, they say the aim is in software. Look at that, digital software failures right there. The aim is not to quantify the failure probabilities, but rather to understand the kind of failure modes that might be introduced. That is to ask, is there a problem here? How might there be a problem here? what would we do if there were a problem here? And Apostolakis points out that QRA analysts, to their credit, haven't rushed to use the models available in the literature that treat software as black boxes and assign failure rates to them based on dubious assumptions. Sheila Jasanoff points out that risk is a construct. It's something that's in our imagination, and we overlay that on the world around us. And the way we overlay it on the world around us is to say, how might things go wrong? Right? We think about stuff that could go wrong. And what we bring to that is based on our experience, old and new, the stories we carry around in our head. It's based on our training. It's based on our knowledge. It's based on our values. It's based on who we think's important. It's based on politics, and it's based on emotions. So it's not an objective scientific process. And facts and values merge when we're dealing with areas of high uncertainty, right? Even if we don't know what the facts are, we can get a feeling about it. Our culture affects the way people think about risk. I'll tell you for sure that people who work at Uber and who were talking about and actually violating the laws, were thinking about risk in a whole different way from the way I think about risk. So in an organization, they're experts in certain domains. They're experts in testing, they're experts in programming, they're experts in the business domain. And I would adapt Jasanoff's talk here to refer to experts and the public as being different domains in a kind of trading zone that we have in a development group. We have to think about public policy. We have to think about social justice. We have to think about whose ox will be gored by this problem. And reconnecting the technical aspects of this is something that is a major challenge. But I have an offering, a suggestion. Instead of calculation, here's what I would suggest that you do if you're thinking about risk in a project. Instead of calculating it, construct stories about it. Because stories are the way that we experience and negotiate feelings about the product until we're ready to take action on them. Such that if we're sitting around a table and somebody says, well, how likely is this? I don't know, not very likely. Well, who would it affect? Well, it'd affect the CEO's daughter. Ooh. Well, all of a sudden, the political and emotional dimensions of quality are right there on the table, because quality is always a political and emotional thing. It's based on a decision about whose values matter. And that comes directly, by the way, from this guy, Jerry Weinberg. It's actually the first book in the series, which would be this one. Quality Software Management, System Syncing. Decisions about quality are always political and emotional because they've got to start with a decision about whose values matter. So we got to talk about that. As we negotiate that stuff, though, vivid ideas about what might happen, what could happen, and to whom, and how it would affect them, those start to become clear in our mind and vivid in our mind until we're ready to take action. So think of risk analysis as the process of negotiating dread on how we feel about the product. That's James's line on it. We're basically negotiating our feelings of dread. So those things are framed by your own experiences. They're framed by stories you've heard from elsewhere. They're framed by things that you have heard about in the world. They're framed by how often, which can be a plus in one sense. Oh, yeah, that happens all the time and nobody really cares about it. Or that happens all the time and people are pissed every time it happens. And in people's minds and in people's feelings, you'll see that flux. Well, let's negotiate like real people about this through this forest of things where we see a particular mushroom or a particular plant or movement from some over the bushes someplace, and we sort out what we know about these things and how we feel about them. Now, at first, when we're speculating about the product, your ideas about risk might be fuzzy and vague, and that's okay. That's normal. We deal with it by doing this really amazing thing that I propose we actually do, and that is learn the product, interact with the product, engage with the product, encounter it, develop experience with it, test the damned thing by using the damned thing. This is the thing, when I look at the landscape of testing in those other three parts of the sort of table that I laid out before there, so much of what we see in testing is like this conspiracy to try to make sure that nobody actually touches the product. I want to get my eyes on the product. I want to get my mind on the product. I want to wrap my head around the product. I want to interact with the product. I want to use the product, and I want to experience it so that I can anticipate how it's going to affect people and how it might threaten their value, how it might be annoying or frustrating or irritating or confusing, how it might engender impatience in me. The reason I want to do that is I want to find problems before we inflict them on an unsuspecting customer. Now, stop trying to calculate risk. If you multiply probability times impact, what are your units? Probability is a guess, impact a guess, so your units are going to be guesses squared, right? Or maybe, since there's more guesses and more factors, maybe we get a huge exponent there, and exponents on exponents. Let's just talk our way through this and ask ourselves, would this be a problem? How big a problem would it be? And if it's a big enough problem, if we know about the possibility of that problem, let's do something to fix it, to address it before it gets out. And not try to distance ourselves from those feelings, but engage ourselves with those feelings. That's how we teach it in rapid software testing anyway. And there's a bunch of readings about risk too, if you want them. I can even copy those, I think, into the chat window.
Oh, yeah.
Which might be useful for people. Let's try to do that. Engineering a Safer World is a really cool book by Nancy Levison. I love the way she talks about complex socio-technical systems.
All right, we got some more questions, if it's okay, Michael. Ramesh had a question on AI and predicting bugs.
Okay, here's my view on that. AI is not a social agent. AI does not think. AI does not feel. AI does not participate in society. Therefore, AI doesn't know the difference between bug and no bug. AI does not know the difference between problem and no problem. It can't. It can't. For me, a lot of this started back in, I don't know, 2006 or 2007 or something. A guy was giving a talk, and I wrote down, as he was giving a talk on why automation projects fail, right? It was one of those talks it didn't have a lot of resonance for me. And the reason automation projects fail, I was writing down, and I asked him a question about it, was because our products don't feel things. Our products don't feel. And he said, well, why would you want your automation to feel? And I said, well, dude, I wouldn't. So why are we getting a machine to do the work of a human here? Why are we bothering with that? Now, of course, we've got to take this into account. This fact that we've got AI coming up. Let's see if I can find this thing. I had the content. Oh, I know how I can find it. I know I can find it. I sent this to a friend earlier today. Let's see. So I read a news story. Here's how it goes. There's a story in a paper, one of those industry papers. Well, what do you know? Corporate America, it seems, is deciding that artificial intelligence might not be such a dumb idea after all. After a decade of skepticism and hyperbole, AI has silently begun to slip out of laboratories and research groups into a host of big business production applications. More companies are using these systems than people think, said Roger Jambor, Assistant Vice President of Customer Technology at the Dun & Bradstreet Corporation. The Basking Ridge, New Jersey firm recently installed an AI system in its credit clearinghouse division that provides credit rating information to small apparel manufacturers, clothing manufacturers. Increasingly, intelligent technology is turning up in diverse industries. In many companies, the focus has shifted from experimentation to deployment. This shift promises a new expansive role for information systems and gives a new hope for survival to battered AI vendors. In fact, the invisible flowering of AI may be one of corporate America's best kept technology secrets. During the last 2 years, most Fortune 500 companies have put AI projects in place, according to a survey by Intelligence Software Strategies, the San Francisco-based newsletter. Despite the recession, 1/3 of the firms say they plan to be spending this year by an average of 43%. Other polls have shown similar high interest. What do you think about that? Right? I mean, that's something really to look forward to. Okay, that's from Computer World, 29th of July, 1991. There is nothing new here. There is something new here, little things new. Mostly the scale of information that we've got to train on, to train deep learning sets on. But here's the problem with that. As Jaron Lanier himself said, you know, we have access to the hive mind through the internet. But Jaron himself said, for the most part, the hive mind is stupid and boring. Who needs it? And in fact, the hive mind is also racist. And the hive mind is also sexist. So here's a big risk for data in deep learning, that the data far too much reflects exactly what we are as a society. And there's some things about us that are wonderful, and there's some things about us that are downright ugly, not nice. But the AI doesn't discriminate. That is to say, it doesn't discern what is good and what's bad. It doesn't have any way of discerning the difference between what's good and what's bad. We have to do that. Now, before the presentation today, I was trying to brainstorm some ways in which we might think about data in AI and risks associated with it. And let's see if I can find it. Here we go. AI is used for classification, and it's used for prediction, and it's used for analysis, and it's used for discovery. But what should it be used for? To my mind, because it's a lens on ourselves, I think the biggest value of AI is as a mirror, not as a lens, but as a mirror to learn about ourselves and about our biases. So, for instance, I've seen a talk in which the presenter was very enthusiastic about showing how AI could evaluate whether we should trust an application or a website or not. And the problem that I had with it was that of the 3 applications that should not be trusted, 3 of them were Chinese, top 3. But my question is, how do Chinese people feel about that? Because this data set and the validation set for it, the training set and the validation set for it, were deployed, evaluated by clearly American, non-Chinese speaking, non-Chinese people. The training sets for that famous case at Amazon, where Amazon was using AI and machine learning to try to figure out who the optimal employee was going to be. Well, the optimal employee at Amazon was going to be a dude between 25 and 45. And what that meant was women wouldn't get hired. And by the way, they'd be white dudes. So people of color wouldn't get hired. This is appalling. This is ghastly. But if we looked at it critically, if we looked at it like testers and said, okay, what can go wrong here? What is AI telling us about our selection process? Whole new ballgame. Now the AI can help us to think critically about things. AI can help us to think, to expose our biases. It can do that in an amazing kind of way. The basic premise behind AI is that it generates algorithms and code in ways that we don't actually understand. And we don't get to see the source code for it either. Essentially, it's the output of a system where either by supervised or unsupervised learning, and by the way, unsupervised learning, that's a crock. Because how did this stuff get into the machine? It got into the machine by a supervisor. A human being chose data to put into that thing. Don't tell me it's unsupervised. Cut it out. But that machinery can, in very interesting ways, tell us about patterns that are in the data that we might not have noticed before, and that's pretty cool. The algorithms that get created, though, we don't have source code for them. They get instantiated as machine code, and we don't know how they got that way. Now, it seems to me we got a bad enough problem with code that we don't understand when we have the source code for it. I think it is really, really dangerous to turn this stuff loose in decision-making processes where we don't understand how it's coming to that decision. It's really dangerous to do that, and we should stop it. What we can do, though, I think what we could do quite powerfully is we could use AI to help us think about how we think and about how we're biased and about whether those biases reveal good things or bad things about it. We could learn in really positive ways from that if we chose to. But in order to do that well, we've got to take a tester's approach to AI and much less of the builder's approach. Don't put it in charge of decisions. That would be automating irresponsibility. That's what AI stands for in that context. So, so how could data go wrong? Let's see if I can find that particular thing, what I made up.
Oh, and Michael, after that, yeah. Richard's been on deck. He's super excited about this, so we're gonna have to let him.
Okay, cool. All right. So let's think about risks just in the data. Okay, the whole notion of forward and back propagation of these algorithms. It tries stuff. It throws a whole bunch of spaghetti against the wall, and with supervised learning, we say that's a piece of spaghetti. No, that's no good. That's piece of spaghetti. That's no good. That's piece of that's not a dog. That's not a dog. That's a dog. That's not a dog. That's not a dog. We have a person doing that. In unsupervised learning, it's a whole bunch of things that the machine finds similar. Well. I wanted to show somebody this too, because this is so cool. Where is it? Oh, yeah, this. It got machines to try to recognize fish, tench, in fact. What were the most important categories or the most important things that the machinery would notice for fish? And the answer was, it identified fish by identifying fingers. Because there's people holding fish. So the machinery looked at exactly the wrong thing. Another case of it was with X-rays, imaging scans. The machinery picked out very reliably stuff that was, that represented cancer. Well, it turns out in the data set that they fed to the machinery, there were identifiers for the hospital that came from. And one of them it came from was a cancer hospital. And so the machine was really, really good at recognizing cancer when there was a slide from that cancer hospital, and they looked at the reliability for that and they said, hey, that's great, but they didn't try with other hospitals so well. So it was just crazy. Anyway, here are some machine learning risks. What slide number is that? 19, Shift F5, 19, enter, there we go. Here we go, transcription errors, unrepresentative data, irrelevant data, erroneous outliers, noise in the data, oppositional data, data that's too uniform, that's crowdsourced. Crowdsourced data is crap. It's terrible. It's not up to date. It's inaccurate. It reflects the bias of the people who put it in. let's relax about all this stuff as being wonderful, and let's look at it with a critical tester's eye. Okay, Richard.
Richard, are you there? You've been on deck waiting. He had a question about automation.
Yes, please tell me about automation. Ask me about automation.
Yes. Costa, is he in? Do we promote him? He's been waiting. Hopefully.
Mute.
Oh,
Okay.
he's here. Good. Okay.
Awesome. Hey, really enjoying it, Michael. Love your passion and love, your depth of knowledge. And, it's to go back step on talking about, you were kind of ranting a little bit against automation.
I'm not
which I
against
take
automation.
which I take personally, but no, I'm kidding. But I wanted to mention it in terms of the growing. There's a couple of things, right? We have DevOps. DevOps is very tools oriented. I personally built a career around automated testing, but the first thing I would say was agree with you that somehow that work, that the phrase manual tester is somehow can be viewed negatively, and I absolutely do not view it that way. I view those people with deep respect, with, like you said, they're system experts. It's what's in their mind, it's what they're imagining, and they're imagining the risk, they're imagining and they have the ownership of representing the user. So all the things you said, I completely agree with. But my question is this: is that to have some of these more, let's say, bigger projects that can afford it or whatever, do you see then maybe 3 roles where you have the developers, the quote manual testers, and then automation and tools people, and then all 3 work together, three roles more specialized?
I love the idea of a position on every team. I think, well, I can't say that because I'm a contracts-driven guy. I can't say every, but I really believe that there should be someone on a team whose job, or part of their job at least, is to create tools for testing. Every craftsperson does this. Everybody who's a genuine craftsperson not only uses tools, but they make tools too, right? They make tools to help them get their job done.
Right.
So a carpenter, for example, will not just make cabinets. A carpenter will make jigs that allows the carpenter to get his or her work done more easily. A clothier, a tailor, will not only use tools, but a tailor will make stuff in order to help that person get work done. And there's enough programming work to do on a project and enough work that tools can help with, that I think it'd be really, really great to have somebody who is nominated, somebody who's designated to be a person who develops and creates tools for testing. But there's a really important but in here. Why are we so focused on checking the code, checking the build, checking the output? Let me give you an example, if I can find it really quickly. I think I can find it really quickly, of a kind of tooling that I think is fantastic. And it helps to shine light on what tools are really good at. And at the same time, it shines light on what tools aren't so good at, and how 2 approaches on to testing can help us to find problems that neither approach can cover in isolation. I'm sort of hesitating a little bit because I'm scrolling through a whole bunch of stuff because I really, really want to show people this stuff, and it's not in that slide set. Dang it. There is a slide set somewhere that has it in it. All right, let me just describe what it is. For a project that we were testing, James Bach and I, for part of the rapid software testing applied classes that we teach, James developed a log analyzer. And the log analyzer did this. It went through the logs, and the log was set up in a really nice way for this. So this was a kind of testability that almost kind of happened by accident. I'm not sure whether it's part of the a development framework that the guy was using or whether it was something that he did himself, but it had which endpoint called which endpoint. And these were lines all the way through the logs. So you look through the logs and you say, this endpoint called that endpoint, this endpoint called that endpoint. And so you could see the kind of network, if you visualized it, of calls between endpoints. So that was one thing that James did. He developed this analyzer not only to identify who called what, but to graph it out. All right. Then he also, James is between the two of us, James is the guy who's going to write the testing tools. For me, James is like a friend with a pickup truck, right? He's, when we're testing something, he's the guy who's going to go out and do the coding. He's more, he's got more of an affinity for programming than I do. I like programming. I've been a programmer. I worked as a programmer for a few years way back there, but for a stretch, I mean, and it was all right, but it didn't engage my passions, didn't float my boat. But I know enough to write stuff like this if I really bothered to. But James is here, so you can do it. So what we did was, he also wrote a set of bots. And to give you a little background, the goal of this product was to find a time when people could meet. So when, you only got 2 people, that's pretty easy. When you got 3 people, it's a little bit harder. When you got 4 people, it's a little bit harder. And it's like the 3-body problem in physics, or the 4-body problem. All of a sudden, it gets really, really complicated. So he set up 256 bots that would, at random, try to figure out when they could make space available for each other. And we got the system to try to deal with these 256, quote, people who all had different agendas and so on. And it was great because that particular stress test, which was fairly easy to code, caused the system to blow up in a fascinating way. Something deep down in the middleware blew up. But what was really cool about it was we analyzed the logs from those bots. And what we saw was a chord diagram that had exactly 3 endpoints on it. One was the starting thing, and one was the offer, and the other was accept, or something like that. That's what the bots were covering. But then we ran the log analyzer on what the testers in the class had done. The human testers, the people who were interacting with the product, the actual testers, not just the testing tools. Here's what happened. It was this rich, spidery kind of network. There's this huge web of connections between endpoints and other endpoints and so on. Vastly more than the bots covered, but here's the coolest part. 2 endpoints, so we had no idea were in the product because we got this thing as kind of a done deal, a fait accompli. So we didn't know those endpoints were there, but a couple of the testers had stumbled on it. So when we look at the data, we say, but what are these 2 things off on the outside of the chord diagram? These were endpoints that we didn't know were there. Well, that's fantastic. That's a really wonderful use of tools to me. I think it's great to have programmers doing automated unit checking, low-level checking on, integrated units, at low levels, at the very point in the product where it's amenable to having machinery interact with it. But to spend as much time as we're spending on this really strange task, let's see if we can untangle it. Somewhere along the line, somebody got the silly idea that it would be a good idea to write down a set of steps for a human to follow, like a robot, that represented in some way what real users would do. And then they would say, get that human to do that over and over and over again. Every time we have a new build, get that human to go through that list of steps as though they were a machine. So what we're taking was a set of tasks that a user might do, and then getting a human programmed like a machine to go through that set of tasks, and then get the human to do it over and over again. Then somebody got a really good idea, so they thought, which is, why don't we take that and why don't we write programs to get the machine to do all the button pressing on that, and then we'll have the machine compare the specified output to, or the output from the product to a specified output that we anticipated and desired in advance. So let's see if we got this straight. We've got people writing a program for humans to follow, and now we've got that program translated into a program for machines to follow. So now, and then we claim that that's a simulation of the user.
Well,
It's not.
yeah.
Why bother doing that?
No, I mean,
Have real people interact with it and check it down at the lower levels if what we're checking is business logic and output.
yeah, I think that I agree. For the yeah, you're not simulating a user.
You're not, of course not.
But we also have we do have systems that are talking to other systems, and in my case it was in telecom, so we were doing things like regressing that if you provision different types of traffic, you know, there's a lot of combinations, and it was an iterative development process. So we just want to make sure that as the developers enhance the product, they didn't accidentally break something that was there. But I agree, it's not human-like use, right?
Well, here's what I would do. It's certainly not human.
And it's not a substitute for humans using it.
But here's the thing that I worry. See, several years ago, I made this distinction between testing and checking, where checking is algorithmic operation, observation, evaluation of the product by comparing it to explicitly crafted algorithmic decision rules, and then reporting the outcome of those applications of decision rules algorithmically. Okay, so is there a key word in here, do you think, that I'm referring to? That's not a bad idea. That's not a bad idea, but it's focused on confirmation. And what I would love to see people doing vastly more than they're doing, or so it seems to me, I just don't hear about it that often, I don't see it happening very much, is using tools to induce turbulence, using tools to induce variation, using tools to amplify our capacity to shake the machine up and rattle it some and see what happens to it. I would, you know, and people say, well, sometimes we do that for a stress test. Yeah, but they do it by doing the same thing over and over and over and over again. It makes analysis somewhat more difficult, but with good logging, we can help with that to some degree. And with better testability, we can improve, you know, our ability to analyze that stuff to a greater degree. But let's use tools to extend our capacity to observe new things. Let's do that instead of having the tool basically replicate bad testing from the 1990s, which was having humans sit in front of scripts and pound on set. We're still partying like it's 1999 in the testing business. You know.
Well, and I appreciate that reference because I'm from Minnesota. That was awesome. Richard, thank you. Everyone that was, Ivan, all the folks brave enough to come on with all of us. Michael, this was a pleasure. We have to do this more often. So I'll schedule another one. I'll have Costa schedule another one and we'll moderate. So.
That's great. Can I put in a plug for my website?
Of course.
www.developsense.com. And we have rapid software testing classes coming up. If people are interested in this stuff, there you go. There's a word from the sponsor.
Hey, that was awesome.